Good afternoon, everyone, and welcome to AABC's Tab Talk webinar series. I'm Colleen McCain, Marketing and Member Engagement Manager with AABC, and I'll be your moderator for today's webinar. Thanks to all our members and non-members across the community for participating today, and a special thanks to IMI Hydronic Engineering for supporting this webinar. I have a few housekeeping notes before we get started. If you have questions for our speaker, please use the Q&A button in your Zoom window and not the chat, and we will feed those questions to our speaker at the conclusion of the presentation. You can submit questions at any time. No need to wait until the end. If you have technical issues, please use the chat box to inform the panelists, and we will assist you. And finally, concerning AIA Learning Unit, if you are an AABC certified TBE or TBT, please allow 7 days for your CEUs to be uploaded automatically to your portal. Today's session topic is healthcare facility compliance, best practices for an independent AABC total system balance approach. Our expert joining us today is Brian Venn from Mechanical Testing, Inc. Brian Venn has 24 years in the commissioning and test and balance industry, ranging from distribution centers to cleanroom environments. His experience is across all aspects of commercial and industrial applications of HVAC pertaining to the MEP discipline. I'll now be handing it over to Brian to get us started. Take it away.
Thanks, Colleen. I appreciate that warm welcome, and also want to thank AABC for this opportunity and putting on the webinar, and also our sponsor, IMI. Thank you for actively participating in the TAB industry. Today, we're going to be talking about healthcare and some of the challenges that a lot of facilities are up against, the new standards that have been put out, and some troubleshooting and best practices that we've learned over the last 2 decades trying to get hospitals to be compliant. So the first thing I want to do really is go into critical rooms and certification and validation. As TAB experts, we are in healthcare facilities every day. And a lot of people don't realize how many environments in that hospital are actual considered critical room or clean rooms and need to be certified or validated. Morgues, operating rooms are obviously pretty high on the list, but isolation rooms, infection control, burn victims, all of that ties into a clean room environment. And a TAB specialist is one of the first line of defenses for any healthcare facility to try to help them maintain the standards, both for the protection of the clients, but also the protection of the employees at the hospital as well. So recently, ASHRAE released a standard 170 update 2021. That's something that everybody will want to look at. It's one of the resources that we used actively to create this presentation. And basically, it came through and called for the critical rooms to be certified for not only air changes per hour, but minimum room pressurization versus the surrounding areas. There was the biggest change, where before it used to be maybe a suggested direction. Now it's actually a measurable value. Minimum operations and maintenance requirements for specific units serving places like ORs or chemo mix rooms. And then obviously helping a facility put together an annual survey, or that facility having an annual survey report at hand with really good photos and supporting documentation for liability management. That's really what the healthcare facility is up against. And the accrediting bodies that look into this vary greatly by region. One of the things I've learned is that I thought that there was kind of like a big three, which there are, but there's also a lot of state and even in some large counties, agencies that are responsible for making sure that those hospitals in their jurisdiction maintain healthy standards, right? And some of the big threes are the Joint Commission, HFAP, and then the DNV. I'm most familiar in a lot of the regions that I work in. JCO is the one that I'm again working with the most. But then I learned when we started to go to other regions that it really did vary greatly depending on whether you were in a large city, a rural environment, and what the hospital or healthcare facility that you're working in, who are they using to get their accreditation? Because that's really where a lot of this the decisions are made is at the hospital level. So, being very adept at understanding these different entities, their expectations will allow you to be ready and have a better standard operating procedure for when that annual accreditation does occur. Again, knowing and understanding that some states actually have their own agencies and even the larger counties. Very important to know these acronyms. Most importantly, how do you stay compliant as a healthcare facility or as a healthcare facility consultant or a facilitator? Be proactive. Help get in a ventilation compliance survey, and by engaging with a certified test and balance firm, hopefully, obviously an AABC firm, but most importantly, a certified firm. Annual test and balance performed in all critical spaces, not only the pharmacy, the procedural suites, isolating rooms, but like I said, also places like the morgue, chemo mixing areas are also critical spaces that sometimes slip through the cracks because they're not thought of every day. But making sure to create a matrix allows you as a facilitator of healthcare or even a tab agency helping out a facility, that matrix will allow you to not miss those smaller critical rooms that may even be in an off-campus facility. So having that matrix is a way of being proactive. Make sure to scope out exactly the deliverable. Are you looking for just the CFMs and pressures? There should be, color-coded drawings prepared by the tab firm for the facility so that there's a map of the space and its relationship to the other corridors around it. Annual commissioning and exercising of controls, in my opinion, is one of the most important things. I know sometimes it's called continued commissioning, but that annual commissioning happening maybe once or even twice a year allows you to avoid surprises on failing equipment. Just simply by going out and making sure that the outside air damper on a critical air handler does indeed open and close as the voltage that it's being sent indicates. And when you're creating a repeatable SOP for compliance, there will not be, or there hopefully will be less surprises during that surprise inspection or even the scheduled inspection. Murphy's Law, if it can go wrong, it may. By doing some annual commissioning and exercising of equipment, Murphy tends to rear his head a little less. So again, just descriptions of, really what is a clean room or critical spaces. Sterile processing departments is another one. Medical and anesthesia gas storage rooms, in addition to labor and delivery, right? That's generally in its own separate wing if you're in a large enough hospital. And then obviously other smaller procedure rooms, depending on the facility, could also fall into the category of clean room. And we're all familiar with the top three top four really, that we were just talking about. There's so many critical clean spaces in a facility. It really is a playground for test and balance companies. Yep.
Sorry about that. This is Colleen here. We're unable to see your presentation, so if you just want to go ahead and start sharing.
Oh, it's not. I'm sorry.
No worries.
I thought I had it shared. I'm very sorry. Thank you for saying that. I am very sorry.
There we go. No problem. We can just start.
Can you see it now?
Yes, we can. Yep. If you just want to go ahead and hit the correct
awesome
slide.
Yeah, I just wanted to make sure
wanted
to make sure you could see it first. That didn't work, did it?
If you put it in presentation mode, it should.
Yeah, the top of my screen is cut off. I'm very sorry.
That's okay. You could run it like this and just hit the down arrow if that works.
Does that work?
Yep, we can see your slides. It's no problem.
Sorry about that. At the top is cut off. So again, sorry about that, everybody. I will just kind of pop up where I was talking about those first couple of slides for a few minutes. The critical room verification, again, we were working our way down to what is actually classified as a clean room. And, you know, clean rooms have many different levels of classifications. With each classifications comes different pressure requirements. You know, clean room classifications are based on the amount of particles that may be allowed per cubic foot in a room. And then, you know, you can find a lot of these standards and acceptable levels in the ASHRAE materials. You know, for example, a class 10 clean room will have a requirement that particle count is not to exceed 10 particles per cubic foot of a size of 5 micrometers and larger, with no particles exceeding 5.0, with airflow, air change per hour, and filter requirements. These requirements should be provided in the construction documents for anybody that is not familiar or where they could be found. And also the owner will generally, who's constructing the clean room, will have their own guidelines and own QA QC requirements and guidelines for us to follow as TAB professionals. So one of the first clean rooms that I'd like to get into is operating rooms. And one of the things that I like to point out to anybody, specifically owners, facilitators, is what you should expect out of a TAB report as a professional. In a TAB report, obviously there should be a description of the room that's being accredited, the area, square feet, volume, its design, air changes per hour, as well as its CFM levels for supply, return, and any possible offset, or if there's an exhaust sometimes thrown in there. And at the same time in that report, if there's any sort of pressure relationship to a sterile corridor or a transfer corridor, those values should also be included and expected to be reported on in the report. You know, some specs don't necessarily always call for this, but I know from working with hospitals that the specs in some cases we're probably going to have to start to get a little more stringent on the asks, because in hospitals it is very, very time consuming to get all of these values, pull them together, and everything is at the end of the line, right? We are the last kids as the TAB and commissioning professionals to get off the bus. So there's always a time crunch at the end. Understanding from the beginning the hopes and asks of the owner or the hospital to make sure that those are included in the TAB report is definitely an easy ask of the TAB firm to make an adaptation or be flexible to their report so that the hospital gets what they need. And generally what the hospital is going to need is whatever JCO or HFAP or the local agency is used to receiving. So there's a lot of times where we really, as TAB professionals, are the keystone to all of this data that's going to help get the accreditation underway and allow the occupancy and the procedures to start in these operating rooms. So the biggest challenge is really raising awareness for what the hospitals should expect in a deliverable. There should be a map showing the space and the relationships to the corridors, as well as the directional pressurization with the arrows. Again, with the new ASHRAE 170 standard, the update of the actual values being written with the arrow is relatively new, and it allows us as test and balance professionals to go and achieve that goal rather than maybe set it up with a directional to 0.01 and we think that that's okay, but the owner and the engineer would have liked to have seen a 0.025 to have a little slop in the pressure at those doors into the sterile corridor. Now with that new standard update, which is really the most important for us as TAB professionals to the 170 standard change, it really does give us better direction on what to set these rooms for. So within an operating suite or operating rooms, there's typically open to, again, that common sterile corridor or referred to as the sterile core, and then into patient transfer corridors. The patient transfer corridor will then access to the hospital through either automatic dual doors or a set of these doors to create a better pressure barrier. And in order to best keep these areas as clean as possible, AABC has joined up and to follow the NIH guideline, which is now they'd like to see or maintain a pressure of 0.05 at the transfer corridors. That's a pretty aggressive number. Unless you're really building a tight corridor, building in a relationship to those transfer corridors, and sometimes it's going to be hard to reach that 0.05. But again, we're finally getting these numbers. I think as energy and the cost and looking at the outside air going into these areas, some of these may down the road be relaxed. I'm not sure, but right now it's a 0.05, and AABC actually is looking for that, for us to achieve that as balancers. The operating room should maintain a positive pressure of 0.02 to the sterile corridors. Again, 0.05 to the transfer, 0.02 to the steriles. And then the sterile corridor should maintain a positive pressure of 0.02 to the transfers. So the operating suite obviously is washing out to these other areas. Critical component to what we do is pressure, right? It's the end all be all. We can set up the CFMs and up to design and the returns and get them all right. But if the actual construction of the room is somehow either subpar or a little leaky, we're still going to have trouble getting to that 0.05. The next thing I'd like to cover is the important requirement stated in the ASHRAE Standard 170 going back to 2008, which states that sterile corridors require 6 air changes of supply air, and they call out a minimum of 2 air changes of outside air to be included in that. So this is, hard for the test and balance professional to do. We're not always able to traverse the outside air going into a room, but we can the supply and the return. So as we're starting to break down these rooms, and according to the standard, look for what the outside air changes are, we have to look at the standard 170, and that will allow us, give us, some path to follow on what we're looking for or what we're trying to achieve. Standard 170 requires that the operating rooms have 20 air changes of supply air, and they're looking for 4 of those air changes to be supply air, and that leaves 16 of them on the return. So if your test and balance companies are only giving you a test and balancing report, and it only on pressure rooms and air change per hour measurements, it's only reporting the supply on positive rooms, then you may not be capturing the return air and understanding how many air changes of outside air will be coming into that room. It's still, I've only seen it asked for a few times, but we're trying to raise awareness of this because as the changing of the guard occurs and the facilitators are kind of turning over, newer facilitators are digging more into these standards and trying to understand them and make sure that they're compliant. So again, a new thing to look for is a possible call for the outside air is going into a room to be accounted for. And you have to capture the supply and the return air and make an inference of what the difference is being the delta on outside air. I know that was a wordy slide. I hope I did it justice. All right. The next room we're going to talk about is airborne infection isolation rooms. So bringing up a map of these, I think that pretty much everybody in America knows what this room is called at this point now, because this is a COVID suite, right? An airborne infection isolation room. As the pandemic took over and took hold, we worked tirelessly with hospitals who were just trying to convert entire floors from what they were previously, maybe suites or patient rooms, and get them to flip over to be an airborne infection isolation rooms because of the massive COVID beds that were required. So obviously these rooms need to maintain a negative pressure at all times for both the health of the residents and workers of the hospital to contain the patient in these rooms. Per standard, again, ASHRAE 170, we're looking for 12 air changes of exhaust now on this side, because again, we're looking to establish a negative isolation environment. So we need the exhaust number to drive that boat. So 12 air changes of exhaust and then 2 of outside air. So we still need to read and record the supply air changes for this room so that we can mathematically come up with how many air changes of outside air that we're coming up with. All AII rooms, excuse me, are generally open to an anteroom, but sometimes they do open directly into a corridor. If there is an anteroom there, it is important to note that it is 10 air changes of supply and 10 air changes of return, and no requirement for outside air on an anteroom for an airborne infectious isolation. So following again with the NIH certification requirements for room pressure, AABC again is suggesting that all rooms should be controlled to maintain a negative pressure adjacent to the corridor of 0.05. An aggressive number, but it is doable when the room envelope is built correctly and we have door sweeps, electrical conduit seals, all the things that would constitute a very well-built tight room are going to be required to get that 0.05. If an anteroom is used, it should maintain a negative pressure of 0.05 to that adjacent corridor, as if the anteroom was, or as if the AII room was touching the corridor. And then the AII room should be controlled to maintain a negative pressure again to the hospital corridor of 0.05, so that there is a negative wash coming from that main corridor. Airborne infectious isolation rooms should require hard ceilings. I've seen them not be installed or a room repurposed. Definitely is not a good idea to have drop ceilings. And then also you need to have doors with sweeps and seals. Obviously the door is where we're looking for that pressure. And sometimes if we don't have proper seals at the base of the door or under the door, then we won't be able to achieve that pressure. And again, all electrical conduits need to be sealed, because I've run into problems where we really took a room to task on why it wasn't passing and leaking. And when we traced out electrical conduit all the way back to the mechanical room, you could feel nice, cool, conditioned air coming out of that conduit, which served the OR rooms. Once we put those seals in place, suddenly the room passed, and it was really just the electrical conduits at that point that were costing us the room performance. So before working in any airborne infection isolation room, a safety note, the room should be decontaminated, so that anybody going in should be safe from any type of contamination, and those guidelines and procedures should be in accordance with the Center for Disease Control. Protective environment rooms. This is your burn victim or possibly immuno-challenged patient, where we do not want any contaminated air coming in from the hospital at all for their own health, whether it's respiratory or surface condition that the patient has. We need to keep them in a positive, clean air environment. So in order to do that, we really do need to take into consideration all the anterooms and the toilets. Again, you should expect volume and area for CFM and for cubic feet in order to understand and create the ability to actually calculate your air changes per hour. Going back to this one. One of the keynotes about these rooms, again, is we want to maintain that pressure. We're looking for a 0.05 between the room and at least the corridor. If there's an anteroom in between, then we'll have the anteroom to the corridor be the 0.05. All right. So when approaching, total system balance for a hospital, we can't do that without actually looking at the hydronic side as well. And one of the biggest challenges that we are seeing healthcare facilities face right now is the fact that prices are increasing, there's labor and material shortages, and sometimes we're having to accept certain things, certain systems, or cut into existing systems rather than put in the new system for the addition. And when hospitals and healthcare facilities do that, unless they start to control the DP in different zones of the system that they're hacking into and adding on to, they're going to start to see problems. One of the biggest consideration is the location of the DP sensors. And one of the things that has been a learning experience for us in our operation is proposing that the DP be controlled in multiple locations, especially when we're on a system that wasn't intended to have an addition added onto it. But now, because of circumstances, we need to go down that route. And when we go out and we're asked to do the pre-demo survey of those types of systems, we always look for what are currently the hardest to reach or the lowest performing sections of those systems. And a suggestion that we would come up with was possibly locating a DP sensor that could be sampled back to communicate with the brain of the pump in the building management system. Locating where it should be. It's not going to always necessarily be at the most remote coil. It could be at the coil that has the largest load, right? It doesn't always have to be the most remote. Tabs should also have a role in determining this location if it's not already shown on the drawing. Sometimes it is, and we'll put an RFI to suggest maybe moving it. And tabs should set the initial maximum and the minimum set points. Now, we have minimum set points in there as something new because most tab specifications call for everything at full load, maximum capacity balancing to prove out, obviously, that the pump and the system can work on a design condition day. But the minimum set points are becoming more and more important for the hospital and the owner and the facilitator because of trying to find the sweet spot for minimum or unoccupied set points for these systems so that they can bring everything down, run the pumps at a minimum, but still serve the critical areas that may still be live 24 hours a day. So I implore all the engineers out there listening to start to look at your spec and start to call out in that scope of work that you also want to see the pumps or fans at minimum speed conditions. It's definitely something that's going to help in energy management in this future where energy is becoming a premium again. There are so many hydronic balancing valves out there. We've often been asked by hospitals, what do you prefer? What do you like? Do we get the smart valves? Do we get the PIC valves? Do we get the auto flows, the cartridge valves? There's really almost a tool for every type of system out there. There really is. And I have to say, we don't necessarily have any favorites, but we do know that to have the proper tool for the job makes the job easier. And one of the things that we're seeing that's not making the job easier for hospitals and facilitators is combining old technology, old traditional, and I'll just use B&G circuit setters or old traditional Tor and Andersons, and then also combining them on a system with new smart auto flow valves. It's causing an issue, and they're not always marryable into a system. So it's not really about favorites. It's about functionality and trying to make sure that the client is going to get out of that system what they're hoping for. Again, putting on an addition to a system that wasn't necessarily maybe intended to have that. We're seeing a lot of these systems where we're just upscaling the size of the pumps for the new sections. Mains, risers, everything is staying the same, but they're changing out certain wings of the balancing valves as they install this new one. It does cause a nightmare when they try to combine it, and we suggest if they're going to do that, it's worth the value and upgrading to obviously smart controllers. Upgrade all of the balancing valves probably to those, and you will get what you hoped out of the design. Again, my opinion, maybe not an AABC standpoint, but something that we've seen out in the field that really has thrown the construction team into a loop as we're trying to bring up these systems after the new stuff has been added on, and we're getting really weird pressure issues out in the extremities of the system. You know, can we get to pressure and temperature ports? Ultra important for the hydronic balancing team to be able to get to these ports. We can't do our job if we can't. Check the details in the drawings for adequate and correct locations. Can the temperature and the pressure devices accurately be calibrated? We say that because often we're seeing oversizing of valves, and you could have a 0.4 or a 0.5 GPM by design valve, but it's coming in a 3/4 inch valve body. Well, unfortunately, the charts on a lot of these valves are limited on how far they can read down on. And in order to get it to perform on that, in some cases, we also have to close the isolation valve to bring that pressure down to a readable, accurately calibratable value. And if that was just a 1/2 inch valve with that fractional GPM, it would have been a better matchup. So that's just, again, living and learning, kind of watching what's going on, making sure that you're not installing or calling for valves that are 3/4 inch to be serving fractional 0.3, 0.4, 0.5, even 0.6 and 7 GPMs as designed. You're going to be operating on the cliff of that valve. So making sure that the device can be accurately calibrated is important as well for the hydronic balancer. Again, there's so many different types of valves that can be used: CBV, pick valves, autoflows. It really is a jungle out there. The engineers have to know what they're installing and approving is going to match up with their design intention and hope for performance. Again, is it accessible, right? Are the valves being installed in a patient room in a soffit that's being sealed up forever during final construction? What happens if we ever need to go back to that? That valve net has to be accessible for both the tab specialist and the service team after we leave. Flow meter location and calibration. This is a big one. More and more we're seeing hydronic flow meters installed, and it is up to the test and balance company to get these calibrated, working with the control guy on his readout. Some of them do come factory calibrated. I do highly recommend that a field calibration gets done behind these valves so that it is checked in the field and it's not sending out some weird numbers that could cause problems. Remember, if a valve sensor or probe is reporting back false information from the field, that's going to cost everybody time, because we're all going to get called into a meeting. The valve installer, the plumber, the pipe fitter, the even maybe the sheet metal guy, who knows? We all will get pulled in, maybe, possibly. I've had it happen to us because we're looking at a false readout on either an air monitoring station or a water monitoring station because it was not field calibrated. Excuse me. Hydronic balancing, again, in hospitals is a little tricky at times because of access, but also because of the diversity of the systems that we come across in a hospital. It's not your normal office building, let's say, right? Now in hospitals, domestic water is a big player, where when I first started this game, it was maybe called out and asked for on 1 out of 6 or 7 hospitals. Now on the ones we bid, it's on 7 of 7 hospitals, right? So understanding all the different hydronic systems that are going to be in your scope is important. You know, the heating water, is there a plan in place? The biggest question is, again, does the owner and the design team have the same goals? That goes back to what I was talking about earlier with the minimum requirements. Getting the pump speed and the pump pressures and the controlling pressure at minimum speed, it's very important to the owners or the facilitators, but it's not in the many specs. So that's a great example of possibly the owner and the design team not having the same goals. making sure having an upfront tab meeting, in some cases on a hospital, just about the hydronic systems is vital. And have an owner rep there to ask them what you're hoping for, go over what you're going to deliver as the balancer. This is what our report is going to include. This is our methodology and our procedures, making sure all that matches up, and your goals as a tab provider hopefully line up with the owner and the design team. Understanding, again, what's important and to who. Domestic water, there's a lot of different varying scopes out there. And a lot of tab firms are still learning and getting up to date on the code and the owner requirements, right? An example of that is, code is 110 degrees, 15 seconds, right? But the owner may require something different. So really, it is up to the tab team to have a better understanding of the domestic water, how to balance it, what equipment is going to be installed on it, and more importantly, is it a potable water rated device that's being installed on it? And then are we meeting up to the owner requirements? Sometimes the drawings will not have adequate information. They'll post a valve type, a valve size, and many times that will be it. Well, we may at times like to or get to more information, like, this size valve body, this size pipe, and at the end for the tab guy, we'd like to see the code requirements for that region. Something in there that gives us a way to reference where we need to go with this domestic water system. Again, they're evolving. They are getting better. I've seen some very good domestic tab scopes coming out recently, but it is a challenge. The tab guys can only do with a system what they're asked if they have values to achieve. Otherwise, we're kind of guessing. We hope it's there. Well, we've got 108 degree water and it's in 9 seconds. Is that okay? Having some tolerance levels for those codes as well and being able to look that information up is important. Pressure independent devices can be used on domestic water systems. Again, as long as they are made for potable rated, or they are rated for potable water systems, and they can save a lot of time and energy in the domestic water environment. So I highly recommend those. So, the real secret in all of this in healthcare environments is controlling pressure, whether you're on a hydronic side or the air side. Getting the pressure right for the hospital on the pumps is just as important as getting the air changes per hours. It's all money. Every BTU that goes into the hospital, they're paying for it. Every CFM they're conditioning, they're paying for. As tab professionals, it is our job, and we are one of the front lines of defenses once equipment is installed and operating, to actually help the owners recognize savings. And we do that by controlling pressure. It's that easy and it's that hard. Understanding the pressure relationship of a room and how it's built will allow you as a tab provider to not maybe over pressurize a room. It's very simple as a tab professional to go in and say, well, just increase the design CFM on the supply of that room that's not making positive pressure. Just bump it up by 200 or 300 CFM. Sure, and that may work, but that may be the final decision that you have to make. It shouldn't be the first one as the tab guys. We should be looking into the construction of the room, doing the due diligence on the windows, the doors, the door sweeps, the seals, and commenting on those faults. If they're missing, again, the electrical seals were not in the electrical outlets. In lesson learned for us, we weren't necessarily sure that we were supposed to write that up as a tab guy, because that necessarily wasn't us. But that, through our due diligence of locating the leaks in the room, that's where it ended up being. So I say to the tab people, in a healthcare environment, anything that could possibly be wrong with the room that isn't allowing you to achieve your pressures, that's an item to be documented. because we are, again, trying to reach this 0.05 that now AABC and the National Institute of Health agree is a good control space, adjacent space pressure to achieve. And if you guys want to find any of this information for yourselves, check out the new ASHRAE standard 170, just updated in 2021. Please note though, however, that each state does have their own regulations overseen by their respective departments of health, which contain their own statutes. So AABC and ASHRAE and NIH, we set up these standards, but there are still bodies and entities within your regions that may have a different say or a different higher or maybe slightly lower standard for what you guys are supposed to achieve or expect to achieve out of your tab firms. And with that, I think I'll hand it over to some questions. I see we have a lot, and I hope they aren't all pertaining to me not getting the first slides up. I'm so sorry.
No problem. Thanks so much, Brian. We appreciate it. Apologies for that technical difficulty with the audio at the beginning as well. So we're going to try and run the IMI hydronic engineering video one more time before we get to questions. And we do have a lot of them, but the good news is we have plenty of time. So let's see if we can get the video back on here for you. All right, thank you. Still having a little bit of a low audio there, but we'll go ahead and dive into some questions here. I know there are a lot, so let's get started. All right, so the first question, Brian, it says, ASHRAE 170 provides minimum required outside air changes for individual spaces. How do you measure OA CFM for any given space?
Good question. This came up before too. You're doing a delta of the math there. So you are quantifying and reading the volume of the supply going into the OR, for instance, and then you're also reading the return either with your hood or by traverse, or in some cases even hooking up directly to the flow ring of the VAV control in the room. So we as tab professionals are very confident that what we're reading is accurate. And then the delta between those two is an inference number, because obviously we can't traverse what that outside air is.
All right. Let's see, another question here. What equipment do you use to measure the air pressure, and at what location do you measure?
I'm sorry, I missed the beginning of that.
What equipment do you use to measure the air pressure? At what location do you measure?
The air temperature?
It just notes air pressure. So
air pressure. I'm sorry, that was one. So
okay.
If you're looking for the pressure going into the spaces, you're reading the pressure either inside the room with your manometer, with a hose going out under the door into the adjacent corridor, whether it's a sterile or a transfer corridor. You want to be either in the space with your tube out so that you're watching the positive pressure flow, or vice versa. If it's easier to work in the transfer corridor or the clean corridor, because some hospitals will want you to stay out of the ORs, you take the pressure from the corridor, put your hose underneath the door into the space, and then calibrate it. A lot of hospitals, when I say calibrate it, will have a monitor on the door as well. And they have a pressure sensor similar to our manometer going through the wall and sampling from the transfer or the sterile corridor to the other space or the operating room. Our readings should be the same. Whatever's reading on the wall should be what's in our manometer in our hand with the hose going underneath the door.
All right. Does the location of DP sensor matter when using trim and respond reset strategies?
Does the setting of the DP sensor, is that what it was?
Yeah.
And what was the last part?
Location of the DP sensor.
I'm sorry, Colleen, it was a little hard to hear you. Well, say that again, I'm sorry.
It says, does the location of DP sensor matter when using trim and respond reset strategies?
I think this is a control sequencing question. I'm not sure if they're asking for the air side or the hydronic side DP sensor. So I'll try to address both. When you're doing air side or water side, if I understand the question correctly, you will have to work with the control guy to adjust the timing of intervals of that sampling and then thus the changing of the speed of the fan of the pump. That definitely has to occur in order to fine tune it, right? But that is also, making sure that we're not operating the system in a sequence that has surging occurring either, right? So the time taken in those samples may need to be drawn out. I hope that answered the question.
All right, next question. Can you comment on allowable ACH setback when ORs are not occupied and best practices?
That's a tricky one. I do not want to guess at this one. I would have to look at the new standard. I don't know if it addresses setbacks off the top of my head, but that is something, again, that a lot of hospitals are starting to look into, especially if they're going dormant and then they know there's going to be a cleaning occurring before they reopen. They're going into those setbacks for energies, but I don't know what the standard at 170 says off the top of my head. I apologize. I'm going to go look that up. But I know, if I could, Colleen, if I could add one thing, I do know a lot of hospitals and hospital facilitators are doing those measures and putting things into unoccupied.
All right.
Colleen, do you mind putting up my contact slide? I saw someone put that up there. Awesome. Thank you.
Yes, there we go. All right. Okay, I just had the next question. Here we go. If AABC recommends 0.05 pressure, what is the minimum required by code? We'll check spec and mechanical design.
I'd have to look up a code. I don't know that all areas necessarily have their own code requirements. Some areas, and I'll use an example in the St. Louis area. That's a regionally controlled agency. Like they do their own inspections. It's not like JCO there or HVAP. So, the code could change from region or municipality to municipality, but I think most of them will default to these ASHRAE standards because they frankly don't know, and none of us do, to how to develop your own standards. Why reinvent the wheel when you have these agencies providing reasonable numbers for you? But again, it does change by region, and some people have different and their own unique rules, which I'm not going to say are unsafe, but they may not be at a level of 0.05. Many hospitals that I work in are more than happy with 0.025, and JCO accepts that.
Next question. It says, please discuss the need for air vents and branch isolation valves to service the system without having to drain the entire system.
Yes, I could definitely attest to that. And I can say that if and I say this with peace and love to all mechanical installers out there. If you follow the detail on the drawings more often, you'll see that those vents are called for pretty much all the time, especially at equipment, but usually at say a return side or a supply branch takeoff. Especially if it's close to a high point, having those vents at equipment and at various positions in the system are advantageous. And if I think that flushing and filling is starting to become a lost art. And I hope that mechanicals invest time and training in their people on how to really do it, because if they do it right, they'll do it once. And if they cut corners on trying to fill it and get a lot of air lodged in and don't flush it properly, they end up spending triple the time it would have taken to probably flush and fill it properly by going back and addressing all these airlocked areas.
Okay, great. Next question. In terms of being proactive in verifying DP sensor locations in the right place, how do you recommend staying ahead of this? Does the owner/CM involve you in reviewing the control submittal? If not, should they?
So they should. The answer should be yes, especially if the hospital has a trusted tab provider that is working on all their systems. It should be an easy answer for us to be included in that decision making. Often, though, we are not. Tab historically is bought out through the mechanicals, and they're not bought out at the same time the GC is buying out the primes. So there could be months in between that contract award and to the mechanical or the sheet metal, and then that award going to the tab firm. In all of that time, equipment has been approved, purchased, and sometime installed. So we don't have a chance to impact or suggest it prior to it becoming a more significant change when you have to pull it or add on to the system. So I implore anybody that could speak to the owner or owners that are educated about the products they're buying out there. You want the tab firm to be involved in it, because a lot of the times we can look at a drawing or a set of mechanical drawings in a couple hours and determine the pitfalls from where the DP sensor is located to having, for instance, the largest VAV demand by CFM and GPM out at the end of the system for the fan and the pump. We're just going over that. And had we been brought on 9 months earlier, we would have brought that up in our design review and submitted an RFI on it. So bringing them in for all of those reasons, not only sensor locations, but also review of even GPMs on the circuit centers. Most tab guys can look at a schedule and look at a bunch of 3/4 inch valves calling for fractional GPM, and that throws a red flag for us right away in a couple of minutes. And going away from this, hydronic engineers, that's the biggest takeaway. Make sure fractional GPMs are getting 1/2 inch balance valves.
Another question here. It says, from the perspective of the person who posed this question, we have been using circuit setters to create a false DP to calibrate the flow, then opening full tilt to limit operating DP. What other means short of strap-on flow meter can be utilized?
I only caught part of that, Colleen, but I heard that they were using the circuit setters to create a DP and then releasing it to control the system based off that.
Yes, it says, to create a false DP to calibrate the flow, then opening full tilt to limit operating DP. And what other means can be used or utilized?
That must be a small system. I mean, maybe it's not, but I would think that would work on some smaller type systems, but multi-story units, stacked units, stacked floors, I don't know that approach will be 100% successful. In some areas, it's definitely going to save energy, I believe. performance, because you don't have all the head pressure built up from the closing of those valves. But I would have to see that. That's a tough question. I don't know that that would apply to every single type of system setup. I'm sorry. I wish I had a better answer for that one.
No problem. All right, we'll just do a few more here.
Sure.
Couple minutes left. Okay, here we go. Next question. I have seen some newer hospitals with ceiling supply and return. Airflow studies prefer ceiling supply and low wall return. What is your experience?
In hospital environments, I do not, in my personal opinion, and I'm not a design engineer, I personally don't like ceiling returns at all in a hospital environment. Even in areas of hospitals where there's no type of procedures and anything, bio going on, there has been samples taken and it's been documented. I wish I knew the sources, but that, there are viruses that are in those ceiling spaces. So I would not recommend using any type of ceiling type return plenums. Just in my experience, they're not handy. They're not going to get it done, and they could present a liability to the healthcare facility. Again, my opinion.
Okay, we'll do two more. Is an air change defined by ASHRAE as using filtered airflow?
Is an air change defined by ASHRAE as being filtered airflow? Is that the question?
Yeah, as using filtered airflow.
I'm not sure that ASHRAE defines your air changes per hour as being filtered. Air changes per hour are quantified by how much supply CFM is being introduced into the room, and then basing that off of the square footage of the room and dividing it by 60 for seconds. So I don't know that filtration has anything to do, but ASHRAE has a lot of language in there. Maybe I'm missing a paragraph or a definition about that, but air changes is more about the volume over time versus the fact of whether it's being filtered.
Okay, last question here. For OR pressurization in similar spaces, what does TAB own for reporting the state and operating condition of AHUs serving adjacent spaces? Since these affect pressurization measurements, this adjacent info can be helpful.
So do you think that the question was just does the state care whether you report the condition of the adjacent areas? Is that what it was, Colleen?
Yes, it was a question about, yes.
So this is changes again by region. Some inspectors may want to see it, and some hospitals may want to see it if that adjacent space could somehow be affected by an elevator lobby, right? So that changes again by region. But as a TAB professional, when we're looking at the drawings, we're not just looking at the areas, we're looking at what else is attached, especially if things aren't going as planned. And we're verifying the design values are reached, that the room or the space looks like it's been constructed properly. Then we start to go to the adjacent corridors and hallways or suites and see what else is going on. We're not always given the drawings. So sometimes if it's not in our scope, we may have to talk to the powers that be about, being, compensated to look at what is going on in the surrounding areas that could be impacting this one small project or this one corridor off of this one small addition. It's a troubleshooting. At that point, it becomes a cascading effect. And it becomes, the bigger the facility and the more corridors off of that room, the harder the needle is to find in the haystack. I hope I answered it.
All right, thanks, Brian. That was the last question. I know there were still maybe a handful out there that were not answered. If you would like those questions answered, go ahead and email us at info@aabc.com, and we can get those questions connected to Brian. Thank you so much. So again, I would like to thank Brian and IMI Hydronic Engineering for sponsoring today. And Brian, thank you so much for lending your time. It was a great presentation.
It's always a pleasure. Thank you.
Thank you. All right, so take the time to take a look at our new AABC free tab calculator app. It has access to over 10 turnkey equations, a scientific calculator, and a resource library. And you can access all of that directly from your Android or Apple device anywhere. And you can download it using the QR code you see on your screen right there, or you can search for the app in the store by typing in AABC tab calculator. So if you haven't already downloaded it, get on the App Store and download it today. Thanks
Colleen,
again, everyone, for your time. Oh, yes,
I
go
could
ahead,
jump
Brian.
in, Colleen, and vouch for the tab app. The resource area is awesome for anybody looking for quick links to HVAC equipment or some type of reference document. That's probably the biggest bonus that I'm getting out of this app. So thank you guys for making it.
Yeah, awesome. We've received a lot of great feedback on all areas of the app so far. So go ahead and download it, check it out, see what it's about. You can take all of this with you in your pocket while you're on site, so it can help you. So go ahead and download that today. Thanks everyone for joining us, and we'll see you again this summer at the next AABC Tab Talk webinar. Have a good afternoon, everybody.